Hello class, this is your instructor Miss Birchfield. In this mini lesson we are going to look at adding, subtracting, and multiplying radicals. To add or subtract radicals, we have to have like radicals. A like radical is a term that contains the same index and the same radicand. An index is like they both have to be a square root or a cube root, a fourth root, and so on. And the radicand is what's underneath the radical. So when we're adding or subtracting, we're looking to have the radicals be the same underneath. So in this first example, we're looking at all of our terms. Notice that all of the numbers are prime that are under the radical. So we can combine the 5 square root of 2 and the negative 3 square root of 2 together. And then we can combine this 2 square root of 3 and 4 square root of 3. So when we add or subtract, we are only going to add or subtract what's in front. So the 5 minus 3 would give us a 2, and the radical stays like it is. We do not change what the radical is. It stays the square root of 2. And then 2 square root of 3 plus 4 square root of 3, we're going to add 2 and 4 to get 6, and then leave the square root of 3 as square root of 3. And we are done with adding or subtracting. So this is our simplified answer. The second example, notice we have a 12 and a 192, which these do not match. But if you go back to a previous lesson when we were simplifying radicals, we can simplify radicals. In this case, we can break both of these down by picking out a perfect square factor. So for the square root of 12, we can break this down into 4 times 3 because 4 is a perfect square factor. Remember your perfect square factors. If you haven't memorized them, it's a good thing to do this. So what we'll do is we'll just take the square root of 4, which is going to be 2, and then we'll leave the 3 under the radical because it is prime. Then coming over to this other radical, 192. 192 contains a perfect square factor. Now you might have to kind of play around on your calculator, and I recommend working from bigger perfect squares down. So if you do this, you would see that 64 is a factor. It is the largest perfect square factor. 64 times 3 is 192. So we can separate each of these numbers. Since 64 is a perfect square, let's take the square root of it, which is 8, and then we're going to leave the 3 under the radical because it's prime. Now we can combine those two terms because they both have square root of 3's, and we're just going to subtract what's in front. So 2 minus 8 would give us a negative 6 with the square root of 3. One more example here is to add or subtract. Notice that the radicands do not match. So what we're going to do is we're going to do some simplifying. So I'm going to kind of separate these and do these individually. So square root of 48, I'm going to bring my 2 down in front. 48 contains a perfect square factor. The largest perfect square factor is 16. 16 times 3 is 48. Instead of separating it, I'm just going to go ahead and remember the square root of 16 is going to give us a 4, and that 4 is not under the radical anymore. This 3 here will stay under the radical, and then we're going to multiply the 4 to the 2 we had in front from the beginning, and that's going to give us 8 square root of 3. This middle term, we're going to do the same thing. We bring down the negative 2 that's in front. 32 contains the largest perfect square factor is 16. 16 times 2. I'm going to bring my -2 down again. I'm going to do the square root of 16 again, which is 4. And then I'm going to leave the 2 under the radical because it's prime. So -2 times 4 will give me a -8 with the square root of 2. And then I'm going to come over here and do the 75. The largest perfect square factor is 25. 25 times 3 is 75. So the square root of 25 gives me 5, and then the 3 stays under. So now I'm just going to put these terms together. And then we're going to combine the ones that have the same radicand. In this case, it's the 8 square root of 3 and the 5 square root of 3. So 8 plus 5 is 13 square root of 3. And then we just bring down the -8 square root of 2. Multiplying radicals, we can multiply the parts. The parts, so multiplication, it doesn't matter what's under the radical. We can multiply radicals together. We just need to multiply what's called the parts. Your parts are in front of and what's under. So let's distribute here. So when I'm talking about a radical here, I'm just using A and B to represent numbers. What's in front would be the A. If there's no number written, it is always understood to be a 1. And then the B, we can multiply what's under together. So we're going to distribute out this first example for multiplying radicals. And we're going to distribute, notice the 11 and the 6 are under, so we can multiply 11 and 6 together, which would give us 66. And then we can do the same thing for this last term here. 11 times 7 would give us the square root of 77. Now, I know just by looking at that those two numbers are simplified because they contain no perfect square factors other than 1. In the second example, what we're going to do, remember, a binomial squared means that you have 2 of these binomials. So what we're going to do is write out twice, and then we're going to FOIL. So I'm going to think about my parts here. So first times first. Well, the 5 is under, so that's going to give us the square root of 25. Outer times outer. In this case, we have a 5 and a -3, so I'm going to get a negative square root of 15. Then we're going to come over here to the inner terms. That's going to give us a negative square root of 15. And then our last times last, a negative times a negative is a positive. Square root of 3 times 3 is 9. Now we're ready to simplify and combine like terms. The square root of 25 is 5. We can combine these two terms because they both have a 15 under, and the number in front is an understood -1, so that's going to be a -2 square root of 15 plus the square root of 9 is 3. We've got one more step to do. We're going to add 5 and 3 together. That's going to give us 8 minus 2 square root of 15. Here in this third example for multiplication, we're going to think about parts. So when we just multiply this by FOILing, notice that the 2 and the 6 are outside and the x and x are under. So we're going to multiply 2 and 6 together. That is 12. We're going to write our square root, and then x times x is x squared. Outer times outer, the 4 is outside, so we're going to multiply the 4 and the 2 together to get 8, and then we just bring down the square root of x. Our inner times inner, we've got a -6 times a 6. That's a -36. We're going to leave the square root of x, bring it down. And then last times last, negative 6 times 4 is a negative 24. We can simplify by combining like terms, but we can also, if you go back to a previous lesson, the square root of x squared we can break down into just x, since it's a perfect square. Then we're going to combine these inner and outer terms here. We're going to, because they both are the same, they both have an x under the radical. So we're going to say 8 minus 36, which is a negative 28. We leave, just bring down the square root of x, and then we bring down the minus 24. At this point, we're done. We cannot combine anything else together. So this is our final product. Here in the last example, we're going to FOIL again. We're going to do 3 times 6. Both of those are outside, so that is 18. Outer times outer, the 3 and the negative 4, we will multiply together. That's going to be a negative 12. Bring down the square root of 5. Here we're going to go inner times inner. The 2 and the 6 we multiply together to get a plus 12. And then we bring down the square root of 5. And then last times last, 2 times negative 4 is a negative 8. And then we can multiply 5 and 5 together to get 25. So now we're going to see about combining like terms or doing any more simplifying. Notice that these are going to cancel, and that the square root of 25, so I'm going to bring down my minus 8, and I'm going to change the square root of 25 to 5. And this is, you're multiplying here. So 18 minus 40 is going to be a negative 22. Thank you for listening to this lesson, and if you have any questions, please let me know.